Okay, we're recording. I'm looking at 7F question 9 in this video. Again, some of the questions in 7F are skipped. I think 7 and 8 they skip. All right, so please refer to your course outline for the specific questions that you should be doing. All right, this one's quite interesting for me because I don't have mains water to my house. I have only water tanks, and I do actually have to do these calculations. The base of the house has this area 110 meters squared, and one night there's 12 millimeters of rain that falls onto the roof. All of the water goes into the tanks. Right. Find the volume of water which fell onto the roof. And what I want to think about is an aerial view of this house. The top of the house would look like a rectangle. Right? They're telling you the dimensions here, 10 meters by 11 meters. Okay? And rain is falling on that area. That area is 110 meters squared. You can imagine, if I can maybe draw this slightly differently, you could imagine that this rain, if it was to pile up on the roof and not go down the gutters, it would make a rectangular prism shape. Right, so we were 10 meters wide here, 11 meters long there, and this height here was 12 millimeters. Okay? To work out volume of this, we'd have to do length times width times height, but we need to make sure that all our units are the same. Okay, so maybe if we let's maybe put everything into centimeters. I could maybe put the millimeters into meters, which would be a valid way to go as well. But it doesn't matter too much because we can always do conversions when we need to. So as long as all the units are the same when they go into an equation, then we'll be okay. So this 10 meters, I'm going to put it into centimeters. That's times 100. So that's 1,000 centimeters wide. 11, remember there's 100 centimeters in a meter. So I'm timesing by 100. 1,100 or 1,100 centimeters. And we had 12 millimeters. So this little height here, 12 millimeters. I can erase that and I'll have to leave it. That's 1.2 centimeters. All right. Hopefully you can see that there. So what I could do is I could work out the volume of rain that's been collected as length times width times height, and that would be 1,000 times 1,100 times 1.2. And my answer will be in cubic centimeters. Okay, so I go to the calculator. Now I've just done this. So 1,000 times 1,100 times 1.2. And I got 1,320,000. Try and remember that. 1,320,000 centimeters cubed. Okay. Now, in terms of litres, if we remember that a cubic centimetre is the same as a milliliter, right? So this is a volume, this is a capacity, but the units are equivalent. There are 1,000 litres, so there's 1,000 millilitres in 1 litre, so this would be 1,320 litres. There are 1,000 litres in 1 kilolitre. This would be 1.32 kilolitres. All right, so find the volume of water that fell on the roof. We should be using this number here for volume. All right, centimetres cubed. And in the next part, how many kilolitres? The answer is here, 1.32. Okay, I might just write these answers near. So I said 1,320,000 cubic centimetres. This is the answer to A. And the answer to B, 1.32 kilolitres. Okay. I could have reported this in cubic metres, this volume. It would be 1.32. Remember, a kilolitre is equivalent to a cubic metre. In fact, we might use that in the next part of the question. So in part C, it says, how much did the water level rise in the tank? And all we know about the tank is that it has a diameter of 4 metres. We've got this tank. It's a cylinder, like water tanks usually are. Right, do they tell you it's a cylinder? Well, they've given you a diagram. I think these days you can get rectangular prism tanks. What I really need for cylinder is a radius. They've given me a diameter of 4 metres. Like you imagine going outside and measuring how wide the tank is, but we need to know that the radius is 2 metres. Okay? And I'm going to use this answer here. It's like the question is sort of leading me into using this kilolitre volume, because that will convert nicely. 1.32 kilolitres is equivalent to, this is the symbol for equivalent to, 1.32 cubic metres. Right? This is a capacity, that's a volume, but they're basically the same thing. All right, volume of a cylinder. I might write this up the top so I don't run out of room. Volume of a cylinder is pi r squared. It's the circle on the bottom or the top of the cylinder times by the height, times height. All right, we know a volume, we know the radius, but we don't know the height increase that we're going to get. Right, so our volume was 1.32, right? Meters cubed. I won't write that in, but it's important. We've got pi times 2 squared, and this would all be times by some unknown height. That's what we're trying to find out, is this height. Okay, so like I'm going to use the procedure we were using in earlier videos. If we did 2 squared times pi and just make this all one number, right? So we'd be saying 1.32 equals some number times the height. So what is 2 squared times pi? What is 4 pi? Let's go to the calculator and have a look. 4 times pi is, it's a bit hard to read, 12.56. Let's make it 12.6. Don't think we need to be super accurate here. 12.6 times the height. But remember, I don't want 12.6 times the height. I just want the height. So I will need to divide both sides of my equation by 12.6 so that I am just left with the height. All right? So we get 1.32 divide 12.6. Now remember, the 1.32 is in metres, right? The 12.6 is also in metres because the radius was in metres. In fact, it's actually in metres squared because we squared the radius. But I just want to point out that we're dealing with metres here. And so our answer for height is going to come out in metres, right? So how much did the water level rise in the tank? We're going to get an answer in metres. We could convert it to centimetres if we want. But let's just do this. 1.32 divide 12.6. So go to the calculator here. 1.32 divide by 12.6. Well, I've got the number here. And that equals 0.105. Let's call it 0.11 approximately. Okay, back to the question. And we are done. 0.11 meters. If you like, you could convert to centimeters, but you don't have to. It's not an awful lot really, is it? Let's have a look at what the book does. Now, I probably should be writing approximately. Approximately equal to. The book says approximately 10.5 centimetres. I think it's okay to go to approximately 11. So the book's answer was approximately 10.5 centimetres. There were no units specified in this question. There was no instruction on how many decimal places. So I would mark this correct, and this correct. In a test, they would all be acceptable. Okay, thank you.